The reject option. Till this point, we have seen multiple approaches for dealing with classification problems. We also saw a decision, how to make decision, and two different approaches. One was minimizing misclassification rate, and the other one was minimizing expected loss. And while we did this minimizations, we understood that there were many cases where we were in a confusion of whether we should put into class C1 or class C2. And in such cases, there will be many situations where it may actually be of C1 but you assign it to C2, or actually be of C2 but you assign it to C1. When will this happen? This will happen when you are not 100% certain that it is of class C1. Under such cases, there is one extra option to reject giving a decision. That is, instead of giving a decision, you leave that part. You say, I don't know. I don't know whether this belongs to C1 or C2. Let us say this is the complete thing. Here it is strongly C1, here it is strongly C2. This is gray area. Let's say here you are not very sure whether it is C1 or C2. So what do? You say, I don't know. Your model can say, I don't know these things. I know these things are C1, I know these things are C2. These points I'm not sure of. So then you can maybe have human intervention for considering these models. So instead of all the points, whatever model can classify, it will classify, and the remaining, the model will tell you that, see, I don't know. So you yourself do this. So what do you achieve with this? With this is, even though there is some human intervention required, you can make sure that there are no misclassifications, because this time if the model is in confusion, it will tell you, see, I don't know. How to implement this? To do this, first thing you have to do is that you have to introduce a threshold. Let's say theta. So what is this theta? Theta is a threshold that you are saying. That is, if this threshold is not crossed, then I don't want to classify it. And what will you put this threshold on? See, in all the previous classification problems, we did classification based on what? Based on posterior. That is, if there are k classes, ck, each of the classes, and let's say there is some probability p of ck given x, where x is your input. Given that the x is the input data, what is the probability that it belongs to ck? If this particular probability, posterior probability, does not cross the threshold, then you would say that it is a reject. I don't want to give an answer here. I want to say I don't know. So reject if the largest of the posterior is less than or equal to theta. That is, for each of the class you find it. That is, if you have class C1, P of C1 given X. For C2, P of C2 given X. C3, let's say you have a third class, then C3 given X. If you are saying my threshold is, let's say 70%, that is 0.7 is my threshold. So if, let us say, my probability of C1 is 0.6, probability of C2 is 0.3, and C3 is, let's say, 0.1. In this case, none of these classes are having a probability of higher than 0.7. That is, with more than 70% of certainty, your model is not about to say that it belongs to C1, C2 or C3. In this case, what would you do? You would reject by saying, because the probability does not cross the threshold, I can't make a classification. So this is the reject option. So to understand the reject option, only thing you have to understand is the concept of theta, a threshold theta, which if not crossed, you will mark it as reject. And what about the values of theta? If you put theta equal to 1, what will happen? All the options will be rejected, because if you have 2 or 3 classes, and let us say even if one class is having probability of 99.9%, 0.999, still because your theta is 1, it will say, see, it doesn't cross the threshold, so I can't classify. And the same case, what if you put theta is equal to 1 by k, or theta, let's just say less than 1 by k. If you put less than 1 by k, what will happen? You have k classes, right? If you have k classes and you take p of ck given x for each of the small k element of k, for each small k element of k, you do this probability of ck given k. If we know it is probability, so the sum of all these, sum of all k should be 1, right? If the sum has to be 1 and there are k different entries, then at least one entry has to be larger than 1 by k, right? If there are k different probabilities and all of them has to sum to 1, at least one among those probabilities has to be larger than 1 by k, or all of them should be equal to 1 by k. So if you put a theta less than 1 by k, that means all your options will be classified. There will be no rejections at all, because whatever case you take, whatever x you take, there will be at least one particular posterior for one particular class which will be equal to 1 by k or higher than 1 by k. So if you put a threshold of 1 by k and say if it is less than 1 by k, reject, then there will be no particular input which is rejected, because there will be at least one particular posterior which is higher than 1 by k, and you will assign it into that class. Let us just see this graphically as well so that it makes more sense for you. So let's say this is my graph, and in this graph, let's say this is my x, this is my x, and I want to see what values of x I want to reject. Okay, and this y-axis shows probability. So this is 1, this is 0, and let us say this is how my graph goes. Let's say p of c1 given x. See, we have two distributions, p of c1 x and c2 x. Let's say c1 given x, p of c2 given x. I'm plotting these two directly posteriors. So if I take c1 given x, let's say c1 given x comes something like this. This is p of c1 given x. Similarly, let's say c2 given x, it goes something like this. Okay, this is p of c2 given x. In this case, see, when you come to these areas, it is having similar probabilities for c1 given x and c2 given x. So you are not sure of what to do. What would you do? You would put a threshold. Let's say your threshold theta is somewhere here. This is your threshold. So if this is your threshold, what happens? Whatever are not above this point, you won't give a particular class, you won't classify it into any particular class. So this is your boundary. See, here you will have a boundary. So whatever comes inside this, in this area, whatever values of x you have, all those values will be rejected. Whatever are in this area, here you know that probability of c1 given x is above theta. So you will put this into c1. Whatever are on the right side of this region, you know p of c2 given x is above theta. So you will put it into c2 class. Here c2 class, here c1 class. But whatever is in the middle, these values of x, you won't assign it to any class, and you would say these are rejected. So here you can add a human intervention where a human being can come and see what is the class to be assigned.